Welcome to this explainer. Look, if you've been working with containers, you already know they're absolutely fantastic for packaging your applications. But when you need to actually orchestrate those containers at scale, Kubernetes introduces a really unique foundational layer. So today, we're going to demystify one of the most critical concepts in cloud-native computing. Let's jump right in and look at the absolute fundamental building block of Kubernetes, the pod. All right, here's our game plan for today. First, we'll officially meet the Kubernetes pod. Then, we'll break down the anatomy of a pod YAML. After that, we'll walk through the pod lifecycle, check out Init and Sidecar containers, and wrap up with the essential kubectl commands you need to know. Starting right off with Section 1, meet the Kubernetes pod. Okay, so what exactly is a pod? According to the official docs, a pod is literally the smallest deployable unit of computing that you can create and manage in Kubernetes. The name itself is a great hint. Think of a pod of whales or a pea pod. A pod is essentially just a wrapper that groups one or more containers together, acting as an application-specific logical host. And what's really fascinating here is that the containers inside this pod are co-located and co-scheduled. They share the exact same network and storage resources. It's kind of like their applications running on the exact same physical server back in the pre-cloud days, making it incredibly easy for them to communicate. Now, we really need to draw a hard line here because these three terms get mixed up constantly by beginners. The node, that's your actual hardware or virtual worker machine. It's the muscle doing the heavy lifting. The pod is that logical wrapper we just talked about, the environment Kubernetes creates. And the container? That's your actual packaged application and its dependencies running inside the pod. So remember, Kubernetes doesn't actually manage your containers directly. It manages the pods that wrap around them. Moving right along to Section 2, Anatomy of Pod YAML. Every single pod in Kubernetes is defined by a very specific structure in its YAML file. It's like its birth certificate. First up, you have the API version and kind. This basically tells Kubernetes exactly what type of object we're trying to create, which, in this case, is a pod. Next is the metadata. This is where you give your pod its name and, absolutely crucially, its labels. Labels are essentially key-value pairs that give the pod its identity, which lets other Kubernetes components actually find and manage it. Finally, you've got the spec. The spec is your blueprint. It details exactly which container images to run, what ports to open, the whole shebang. Okay, Section 3, the pod lifecycle. Let's look at a day in the life of a pod. So unlike a traditional server that you might keep running and patching for years on end, a pod's journey is meant to be completely ephemeral. They are temporary. A pod transitions through some very specific, heavily guarded phases. It starts out in a pending state, moves into an active running state, and eventually reaches a terminal outcome, either succeeded or failed. And here's the kicker. Once a pod is bound to a node, it is never rescheduled to a different one. If it dies, well, it dies, and a brand new replacement pod takes its place. Let's zoom in on these phases just a bit. During that pending phase, your pod has been officially accepted by the Kubernetes cluster. The YAML was totally valid, but it's just waiting. One or more of its containers hasn't been set up yet. Maybe it's waiting for the scheduler to find a suitable node with enough CPU and memory, or maybe it's just waiting for that node to finish downloading the necessary container images over the network. Once those images are pulled and the pod is bound to a node, boom, it enters the running phase. This means at least one container is in there executing without any issues. From there, it'll eventually hit a terminal phase. Succeeded means exactly what it sounds like. All containers in the pod finished perfectly with a zero exit status. They did their job and they're done. Failed, on the other hand, means all containers terminated, but at least one crashed or exited with a non-zero status, and the system isn't set up to automatically restart it. Which brings us to Section 4, Init and Sidecar containers, or as I like to call them, the roommates. Now, the one container per pod model is definitely the most common, for sure, but some advanced setups require tightly coupled containers working together in the same pod. The two big multi-container patterns you need to know are init containers and sidecar containers. Init containers are like the setup crew. They are specialized utilities that run sequentially to completion before your main app containers even start. They prep the environment, like maybe delaying startup until a database is ready, or fetching a secure secret. Sidecar containers, though, they run continuously right alongside your main application. They don't run the primary logic. They're just there to provide supporting functionality. And this quote is a brilliant real-world example of why sidecars are so incredibly valuable. Straight from the NSA and CISA Kubernetes hardening guidance, it highlights the logging proxy pattern. Basically, instead of hard coding a bunch of logging mechanisms directly into your main application, you just use a sidecar container to independently grab and forward those logs to your security backend. Because sidecars share the same file system and network as the main container, they can literally just access the app's output streams without you ever having to alter the main app's code. It is an absolute game changer for security and keeping your concerns separated. Finally, Section 5, Essential kubectl commands. Let's talk about taking control. Knowing how to actually manage these pods once they're out there in the cluster is, well, kind of the whole point, right? So here is your essential toolkit. You've got run, which you use to quickly create and start a singleton pod. If a pod seems stuck in that pending phase we talked about, you use describe. That's your detective tool to view its detailed state and figure out why the scheduler hasn't placed it. You use logs to see the actual output of your containers, which is perfect for checking if that sidecar logging proxy is doing its job. And finally, exec. You use this to open up a shell and execute commands directly inside a running container when you need to do some deep, hands-on diagnostics. As we wrap up this explainer, I want to leave you with a bit of a provocative thought. We've firmly established that a single pod is mortal, it's disposable, and frankly, humans rarely create them directly in a production setting. So if your application needs to survive node failures, scale up automatically during a massive traffic spike, and perform updates without any downtime, what higher-level Kubernetes controllers are you going to use to manage an entire fleet of these disposable building blocks? Think about things like deployments, stateful sets, and replica sets. Because honestly, that is where the true orchestration power of Kubernetes actually begins. Thanks for joining me for this explainer on Kubernetes pods. Keep learning and keep building.